The next question of today weekly coding contest is make lexicographically smallest array of lexicographically smallest array by swapping elements. So that means they will give you sub elements and you have to perform some swapping operation, and after swapping operation you have to get the minimum lexicographic smallest lexicographical array. But the for swapping there is a constraint. You can swap only those element. You can swap only those element. Their difference is less than limit. So this limit is constant. If two element having a difference less than that limit, then you can swap that one. So let's understand by this example. Suppose we are having 5 1 5 3 9 8. So we can swap 1 with 3, 3 with 5, and so we can swap only just 3 element in this group. Otherwise we can swap 9 with 8. So we can swap this type of swapping operation. So first understand what is the lexicographically order, and then we will proceed. So suppose we are having 3 element, 1 1 2 and 3, 1 2 and 3. So the lexicographical order will be 1 2 1 2 and 3 will smaller than 1 3 and 1 3 and 2, and it will be the smaller than 2 1 and 3. So for better understanding, you can read once in the question. In question also they have provided the definition lexicographical order. So let's proceed in solution. So in solution, suppose we are having one array, array element is 11, 11 1 11 1 6 3 18 5 and 8. These are the elements we are having. And their corresponding index is 0 1 2 3 4 5 and 6. So we can swap 1 with 3, we can swap 3 with 5, we can swap 5 with 6, and we can swap 6 with 8. And we so on we can perform some swapping operation, and after performing that swapping operation we will try to put all the smallest element in left hand side and increasing order. So we will try to make it as increasing order as possible. So first we will try to push 1 here, then we will try to push 3, then we will try to push 5, then we will try to push 6, then we will try to push 8 from left to right. That will give you minimum this will give you smallest lexicographical order. So for making that one, first we will try to check what are the element that we can swap. So we can swap 1 with 3, we can swap 3 with 5, we can swap 3 with 6, 5 with 6, we can swap 6 with 8. So these are the elements we can swap. So for that, first we will make a list of how many element we can swap. So we can swap 1 with 3, and then we can swap 3 with 18, or 3 with 5. Then we can swap 5 with 6, and then we can swap 6 with 8. So if we can swap 1 with 3, 3 with 5, 5 with 6, and 6 with 7, and their consecutive their adjacent difference is also less than 2, so we can swap this element in increasing order in that, in those particular group index that they belong to. So suppose if the elements is 1 3 1 3 5 6 and 8, and indexes that they belong to 1 2 3 5 and 6, so we can arrange this element in increasing order on these indexes. So we'll find out how many the connected group that we can swap, how many connected group that we can swap, and their indexes, and we will sort their value. We'll sort their value in increasing order, and then we will swap their indexes in increasing order, and after that we will make two pointer. First pointer will point the value and second pointer will point the index, and will increment the indexes value from left to right, and will increment the element value from left to right, and then we'll assign suppose this variable is v and this variable is I, so we will assign v value in ith place in original array. In this way we can get the sorted, in this way we will get lexicographically smallest set. So the next question is, how we'll find out what is the group of element that we can swap in between, so we can arrange that group in ascending order. For that we have to make pair of, first we will make pair of value and their index. So suppose we are having element x1, x2, x3, x4, x5, x6, and so on xn, and their indexes are 0, 1, 2, 3, 4, 5, 4, 5, 6, and so on n minus 1. So we'll make pair of 0 with x1, 1 with x2, 2 with x3, 4 with x4, 5 with x5, 6 with x6, and so on. Here we have made one mistake. So we'll make pair of value and their index. So we'll make a vector of pair of value and their indexes, and after making pair we'll sort that vector. We are making pair of value with index, so that after sorting also we can know what is the actual index of that value in original one, and we are sorting that one so that we can make a group of closest elements in original group, so that we can rearrange those elements. Because we have limit constant, we can rearrange only those elements with their difference, if there is difference is less than that limit constant. So that's why we are sorting that element, and we are making pair, because after sorting also we can know what is the original index of that element in array. So here is code for the same. So first of all, we'll make a pair of value and their index, and after making pair we will sort that array of pairs, and after sorting we will make two different vector. One vector will keep track of value and another vector will keep track of indexes. As and after sorting, whenever get we are next value, if a value is greater than already the all last value that present in value index having difference less than limit, so last value of, suppose we are having value either 1 2 5 and the next value we are getting is 7. So if 7 minus 5 is limit less than limit, then we'll put that 7 in 5. So now our next array will be 1 2 5 and 7, and and with that we are also storing the index of 1. So first index, suppose this index is I1, this index is I2, this index is I3, and this index is I4. So on will proceed. Whenever this relation will not hold, we'll sort that element in increasing order, so that is already sorted only, and we'll sort their index value also increasing order, so that the smallest value comes in smallest position and largest value comes on farthest position, leftmost position, rightmost positions. In that way we'll make them in increasing order in original array. So this is a procedure, and after making change in original array, again we will start with new. Again we will after making change. So if this relation hold, we will push the value in value array and their index in index array. And if that relation is not hold, then we will sort the index array in sorting order, increasing order, and we will sort the value in increasing order. And for each value that we are getting in sorted list, sorted index, we will update the smallest value in smallest position and largest value at largest position in original array. And then we will clear the that vector of value and that vector of value and that vector of indexes, and we will again reassigning the value from that position. And this is for if after all the elements, if after the one more thing is we are making update in original array when this relation fails. But what happen if we traverse all the element and this relation will not fail anywhere, all the element is in belong to same group? Then after that for loop we will again check if there some element present in the vectors or not. If some element is present in that vectors, then we'll again make some changes according to that vectors in original array, and then we'll return the original array. So this will give you the smallest lexicographical uh, arrangement of the original array with this constant, so that we can swap only those element which having difference less than limit. So time complexity of this method is we are making couple of sortings, so it will take order of n log n, and apart from that we are having one for loop, so it will take order of n. So time complexity will be n log n, and we are using some extra spaces, so we are using order of n extra space. I will put the code for the same in description. You can go through of it. So this is the code.